Hi, everyone. Welcome to our second enterprise webinar. We're super excited to be here with all of you. The first one went really well. And today we're going to be talking about function calling, tools, and agents. And this will be a fun webinar because we've split up the webinar into two sections. We're going to do some overview to start to highlight some of the things that we want you to take as kind of the key points, and then we'll transition into some live coding so you can see some demos as well of what we're talking about. And as always, just some housekeeping. Please feel free to ask questions in the chat. I will ask them live on your behalf, and I'll also create some space for others to contribute to the conversation as well. So we'd love to make it interactive. So introduce yourself, and if everyone wants to just say hello in the chat to get started, that'd be wonderful. Take it over to Harrison.
Yeah, absolutely. Thanks for joining. This is going to be a fun one. I'm going to go ahead and share some slides to get started. All right, can you see my screen? Okay. Yes?
Yes, you're good.
Cool. All right. So yeah, wanted to talk a bunch. So when we initially thought of this, wanted to frame it as kind of like a state of tool usage. So how to enable language models to best use tools. And so that was originally in the context both of agents, but then also outside of agents. So I think like an example of this is just having a simple chain that calls an API. Like you can imagine the API is a tool. It's got a description of how to use it. It's got some inputs with some descriptions. It's got some desired output. And so how do you best use those types of tools as well? This, as we'll talk about a little bit, the best way to do this, if you don't have any constraints at the moment, is probably with OpenAI function calling. And so it'll also dive a little bit into that. So there's some of this which is going to be a little bit OpenAI functions specific, but then there's also some general kind of like learnings as well. And so happy to spend more time on either one, depending on what's interesting to you. I'll also note that even though function calling is OpenAI specific, one thing we have added in the LangChain library is an Anthropic's function wrapper, which basically exposes the same API that OpenAI expects around functions and uses Anthropic under the hood. And the way that we do that is we just insert it into the prompt using some XML tags, because Anthropic's really good at XML. And we're happy to do this for more language models as well. So even though some of this may appear very OpenAI specific, we're happy to make it not OpenAI specific, and if that's interesting as well, also happy to chat about that during this webinar. So yeah, the two things that I want to cover both on the slides and then also in some notebooks, because I thought that would be fun, would basically be kind of like function calling by itself, and then some use cases for function calling. So do an overview of function calling, talk about how to make it easier in LangChain with Pydantic or Zod, talk about some prompting strategies. So that will probably be mostly the conversation on the slides. And then there's a bunch of use cases as well that I want to walk through in the notebooks if we have time. And some of these are specifically around kind of like tool usage. And then other ones are around using tools to basically structure the output in some way. So if you think about what tool usage is, it's calling some function with some inputs, and that can kind of be thought of equivalent as basically returning structured output. And so there's some good kind of like structured output use cases that I'll probably spend less time on today than the other ones, but if that's interesting, happy to dive deep in that as well. So if people aren't familiar with the function calling ability of OpenAI, it's an OpenAI specific syntax or specific parameter. So you can specify two additional parameters, function call and functions. Functions are basically a list of functions that the model may generate JSON inputs for. And then the function call is a way to force it to call a function or to not force it to call a function. And so what it looks like, if you look at on the right here, you can see that this is a list of functions. There's one function, it's called get current weather. It's got a description, and then it's got some parameters. And so the parameters are, there's some properties. This is describing the parameters, its location, and then unit. And then each has its type. This is an enum, so it's got some values. This is a description. So this is new parameters introduced by OpenAI roughly 3 months ago. And under the hood, they fine-tuned a model to be really good at outputting things in this format. And so it might be worth actually looking at a second for what the outputted thing looks like. So I'm going to switch to this notebook because I think I have an example handy. And so we can see here, I'll zoom in. So we can see here that what the model responds with when, and I'll walk through this in more detail, but just highlighting the response. The response is a function call. So now this is different than the content. So this is a different output field than the content. So it's two separate fields, and that'll be important for some details later on. And then the function call denotes the name of the function to call. So this is weather search. And then the arguments. And the arguments are returned as a JSON blob in theory. So the model's been fine-tuned to return a JSON blob, but it doesn't always return JSON. So one of the things that you'll have to keep a little bit of an eye on is that it actually returns JSON. And that there are definitely cases where it returns invalid JSON, and so it's good to have kind of like catches for that. And this is a little bit on the inputs and outputs of the function calling ability that OpenAI added. One of the things that we've added in LangChain is a little bit more user-friendly way to create these function descriptions. So as you can see here, this is a big blob of data. It's mildly annoying to work with, and so Pydantic and Zod in Python and TypeScript are two basically like libraries that are really good at representing data. And so in Python, what it looks like is you can use Pydantic, you can define a base model, and so it's just like this. So you have a class, the name of the class, you inherit from Pydantic base model, you have a doc string, you have a field, type, a description for the field, and then we have this nice little utility function called convert Pydantic to OpenAI function, which takes in a Pydantic model and converts it into the format that OpenAI functions expects. So we'll use this pretty heavily in some of the code to work with a lot of these functions. The last thing I want to talk about before talking about use cases is prompting strategies, which really equivalates to just how to use these functions, because at the end of the day, the functions are still prompts. The functions, what's going on under the hood is so OpenAI's models use a specific syntax called, I think it's chat-ML syntax. And basically, by the time it goes into the language model, it's all one string, or rather, it's all one sequence of tokens. And so the functions get inserted into that string or inserted into that sequence of tokens in a particular way. And so what that means is that functions are still prompts. So specifically, they count against token limits. So if you're using functions that have long descriptions or a lot of parameters or something, that'll increase your token limit usage. And then that also means that the way that the language model knows how to use these functions is how you describe it. So what the name of the function is, what the description of the function is, what the name of the arguments are, what the description of the arguments are. Those are all really important for having the model know how to use it. You can provide other information as well, so you can still provide examples for functions. And there's a few different ways that we see people doing this. One way that we see people doing this is just by inserting into the system prompt or something a list of kind of like inputs and then function call. That's a little bit of that's a slightly easier way, but a bit more hacky way. Probably the proper way to do this is by passing in, you can pass in messages and you can mark them as example equals true. And so you can do this with function calling as well. So you can pass in like a human message with example equals true, and then you can pass in AI message, which has this function call invocation as example equals true as well, and do a few shot examples of those. You can also provide some examples in the description of the function itself. So in the doc string, you can provide some example inputs and some example outputs. So there's kind of like three different ways that we see people providing these examples. We haven't done any kind of like super rigorous study to determine which one's the best. I'd probably guess the way of providing it explicitly with the example equals true and distinct messages, that would probably be the best. Although it's a little bit more unwieldy to work with, so it might not be the fastest one. One question that we get a lot is what is the optimal number of functions to pass in? And I think we generally try to recommend, so somewhere between 5 and 10 is probably like the most that you should have. And basically because what starts to happen is, one, this starts to count against the token limit. So it creates a larger prompt under the hood. And as the prompt gets larger, the model gets a little bit worse at distinguishing between functions. There's a bunch of, so this ties in a little bit to some of the research that's out there in terms of like long context lengths and how much those long context windows actually improve things. And so as you start to improve, or as you start to increase the length of the prompt that you're passing in, it starts to pay, the current research shows that it starts to pay a little bit less attention to some of the details in there. The other thing more practically is, even as a human, if I have to choose between 10 different functions that I can call, that's a lot harder than having to choose between like 5 or so. And so I think that leads naturally to the next question, which is, okay, how do I work with many functions? Because oftentimes I have more than 5 or 10 functions that I want the agent to be able to use. And so the main thing that we've seen done here with success is basically group those functions into groups of like roughly 5, and then create like specific. This is talking about agents. Create a specific agent for that function, or a specific chain for that function, and then basically have kind of like a router chain or a router agent that decides which chain or agent to call under the hood. So it starts to look a little bit hierarchical. So to make this concrete, let's imagine I'm like building kind of like an executive personal assistant or something like that, and I want to give it access to like 5 tools that have to do with Gmail, like read email, write email, read calendar, or something like that. I want to give it access to like 5 tools that have to do with Slack. I want to give it access to like 5 tools that have to do with Notion, and 5 tools that have to do with GitHub or something like that. Rather than kind of group them all together and have like a list of 20 tools, what I can do is I can create 4 different chains or 4 different agents. One for Gmail, one for Slack, one for Notion, one for GitHub, and have one kind of like router agent that can call these kind of like independently. So it can say, hey, go like check my email, and then go check my Slack. Or depending on how you set it up, it can do those in parallel and then come back. So we see this kind of like hierarchical grouping work relatively well, and that's probably the best way that we see to work with many tools.
And Harrison, when should people consider using function calling versus just passing in a natural language prompt? Certainly structured data for chatting your data, maybe you want to leverage functions, but when is it not a good idea versus when is it useful?
Yeah, so I'd say like anytime you're spending a lot of time and tokens in the prompt on instructing the language model how to respond, the format, the specific format and syntax in which it should respond. If you're able to use function calling, you should probably just use function calling in that situation. So I think like if you look at some of the prompts in LangChain on agents, they have some chunks in there that are like, hey, respond in like JSON format with like action and action input. So that's a lot simpler to do with function calling. If you look at some of the prompts in LangChain around using APIs, again, it's like respond in this specific format, and so that's easier to do with function calling. Even things like QA with sources, so doing question answering and responding with sources. I think the way that we've implemented that in LangChain natively is we ask it to respond. We ask it to include kind of like a sources colon and then a list of sources after that. That's probably more reliably done with function calling, would be my guess. That's just to get a little bit on the border. But basically, anytime that you're kind of like spending some tokens in the prompt, trying to get the language model to respond in a specific syntax, if you're able to use function calling, I would probably opt towards that.
And we had another question in the chat. How can we ensure the right function is used? What if we need to adjust? Can we fine tune? So I think we're going to get into that too in a little bit, but making sure that you select the right function.
Yeah. So that really comes down to kind of like prompting. So at the end of the day, it's prompting. So does the language model have all the context that it needs in order to know that it's making the right tool selection? So if it's messing up, if it's choosing a wrong tool, like why is it choosing the wrong tool? Is there another tool and it's unclear what the difference between those two tools is? And so then maybe you need to improve the description of some of the tools. It is if it's not choosing the tool at all, do you need to improve the description of the tool or description of the system prompt to say when to use tools versus when not to use tools? So there's a lot of prompting that still goes on in order to get it to use the right tool. The other thing I'd say is we have seen some companies, including I think Cal.com, who launched their AI agent on LangChain over this past weekend. I think they're using a fine-tuned model from OpenAI that does function calling. So if you get to that point where you're looking to productionalize something, you want a little bit more reliability, fine tuning is an option now. So when fine tuning first came out, you couldn't fine tune on function calling. You now can, and so that is an option to kind of like get it to choose the right tool. And I'd say that's kind of both that and prompting. What they're really doing is they're just providing like the right context to the language model, and it's just different ways that you're providing the context. So in prompting, you're providing the context in the prompt. In when you fine tune, you're just providing the context in the examples, which then update the weights of the model. And so something in the middle could be to try using some few shot examples to improve results, and that's kind of like maybe like a step in between. And I think fine tuning is maybe like a different conversation. If you have kind of if you know that you're going to do this task and you kind of like have product market fit with that, and you really want to improve accuracy and maybe latency and cost as well, depending on the exact prompt, I think fine tuning is good. But if you're still exploring, I would definitely do more of the prompting, move into the few shot examples, and not jump right away to fine tuning. Cool. Okay. Some of the use cases, and I'll just skim over these quickly because I think they're maybe a little bit better shown with actual code and actual notebooks. So first is kind of like tagging, and this is really just responding in a structured format. But the use case specifically is if you have a document, you want to basically evaluate it according to some criteria. So to make this really specific, if I pass in a document, I might want to tag it with some metadata features like the language that it's in, the author that it's in, or the author that wrote it, the sentiment of the text, things like that. And so I want to extract all these different attributes, and so I can just tag the document with that. This is a little bit different than extraction. The idea of extraction is you may have like multiple entities that are mentioned in the text. So you might have multiple different people and their ages that are mentioned within the text, and you want to extract a list of these entities. And so the distinction is basically tagging is kind of like one classification for the whole text. Extraction is like extracting out distinct kind of like entities within the text. And then yeah, the third one is just like these are kind of like just generally structuring the response. So like doing question answering and citing sources and making sure that sources is a list of strings. You could argue that's tagging, but that's just like generally structuring the response. And so going back to like when to use function calling, any time that you're structuring the response, I think is a good time. And then the fourth one is basically tool selection. Yeah, so figuring out kind of like which tools to use, what the inputs to those tools should be, whether it's an agent, whether it's calling an API. That's a really good use case for tool selection. And so I'm going to hop over here and show some of the notebooks. So this is all at this GitHub repo. HW Chase 17, AI Engineer. There are a few different notebooks in here. The first one goes over LangChain expression language, which I think we'll probably do a deeper, well, we're definitely going to do a deeper dive on that in the community over the next month or so. And so maybe we'll do the next enterprise webinar on them as well. It's basically a new syntax that we've been rolling out over the past 3-4-ish months that makes it easier to compose chains, easier to inspect what's going on. You can add fallbacks, error handling, lots of cool stuff. Not going to go over that notebook in this lesson, but if you're not familiar with LangChain expression language, we will be using it throughout. So this is a good reference for that. And then otherwise, going to try to go through just function calling basics in a notebook, then kind of like tagging and extraction. So this is one use case, and then tools and routings. And then if we have time, jump into like a conversation where you're using functions, aka an agent, basically. So that's kind of like the plan. All right, function calling. We're going to use Pydantic to structure a lot of the functions and create them. This is, if you guys aren't familiar with Pydantic, it basically makes it adds two things. One, it adds a lot of things, but it adds two things that are nice for this specific use case. One, it makes it easier to create these types of classes. And two, it actually adds validation on these classes as well. So if we look at this class, we can do stuff like this. We can also do stuff like this. So we pass in an invalid thing for name, and which is an integer, it should be a string. It doesn't throw an error or care at all. If we now use Pydantic, so this is a little bit simpler. So you can see that there's three kind of like things here. We don't need to do the init. We don't need to set name equals to name. We can kind of just define it. And then we can initialize it in the exact same way. And it also throws validation errors now. So if we pass in a string for age, it erases an error. We can also nest Pydantic models as type hints. So this will become important when we want to extract lists of things. So we can see here we define a new Pydantic model. It's got students, which is a list of p user, which we defined above, and we have this object. So that's a little bit of a quick basic overview of Pydantic. I think I showed this already, but we now have this nice util where we can easily convert this into an OpenAI function. So specifically, we can see that the name is the name of the class, the description is the doc string, and then the parameters show up in parameters and under properties specifically. So airport code, description becomes this field description, and type is that type. We do require that it has a description. This is you can create a Pydantic model without a description, to be clear. But when we convert the Pydantic to OpenAI function, we do require that it has a description, and that gets back to this is prompting at the end of the day. And if you don't really provide a description for your function, the model's probably not going to know how to use it. If you really don't want to provide a description, I think you can just put an empty doc string like that. Okay, maybe not. You can't even do that. So this is a little bit opinionated, but this gets back to the point that this is prompting. And so if you don't provide a description of what the function is, it's not going to yield kind of good results. You don't have to provide descriptions for the fields though. So if you just do this, there's no description, and it won't show up. But if the name is human readable enough, that's probably fine. We can see how to use it. So we just pass it in. So invoke is a new thing with LangChain expression language. It's a common kind of like interface that all chains, LLMs, retrievers now have. So it's just one way to invoke things. There's other things as well. There's batching, there's async things, there's streaming that, again, all functions, chains, retrievers have natively. That's probably a separate conversation. So you can see that one way to call this is we can just pass functions into the model like this, and we can get back something that looks like this. There's no content here. There is content in the function call. Importantly, there can be content here and a function call. So we could say like, say hi, then what is the weather in SF? And hopefully this does, yeah, so now there's content and there's function call. So it is possible that there is both. there's some more nuance to that later on, but we'll get to that. Another way to use functions is to bind them to the model. So what is binding? Binding is basically adding keyword arguments so that they're always called when you call model with function invoke. This is really nice if you don't want to always have to have these floating around. And so to kind of like bundle it up and make it more concrete, you can bind it to them. And then when we do this, it should, do the same thing. All of this stuff also automatically gets logged in LangSmith. So if we open up LangSmith, we can see exactly what's going on. Because we're just calling the language model at the moment. So we can see that we have our human message here. We can see the AI message that responds. The function call is represented there. We're doing some work to make this look a little bit nicer. And then if we go to the metadata, we can see the list of functions that we call it with. And again, we're doing a little bit of work to make this nicer. One thing that we can do is force it to use a function. And so the way that we can do this is we can pass in this additional argument, function call, and we can set name equals weather search. And this basically forces it to call weather search. And it forces it to only call weather search. So if we now call this and tell it, say hi, it actually won't say hi. It'll just call the airport code. If we call it with something that doesn't even need the function, it'll still use the airport code. So this forces it to use the weather function, which is good in some cases, and we'll see some use cases where we want to do that, but it's bad in other cases where you want it to give it the flexibility. So you shouldn't always use it, but it's an option. And then what we can do now is we can use this in a chain like we always would. So we'll create a prompt template. We'll now create a chain. This pipe syntax is part of LangChain expression language, and so you can easily kind of like join two things together. So prompt model forced function is forcing it to use this thing. And then we can call chain.invoke, same thing. The input is now a dictionary because the input to a prompt is the dictionary. And we can see that we get the response back. If we go into LangSmith, we can see that we have this runnable sequence now, which we can show all run stats for, see kind of like the steps each part of the sequence as well. We can also pass in a list of multiple functions and have it choose. So we set up a new function called artist search, same thing. We set up a new list of functions that has both weather search and artist search. And now when we call it, it can choose which one to use. And so this is really powerful for having it choose between tools. That's the basics of function calling. So I'm now going to go on. Actually, any questions about the basics of function calling before we go on to the use case stuff?
Maybe one question. You showed how you can bind to a particular function or force it to use a particular function. Do you recommend doing non-deterministic routing for those types of use cases, or still using LangChain to if you're going to bind to a particular function route?
So that's a great segue. So the main place that you bind to a function is actually when you want to force it to respond in some syntax. So for everything like agents, you don't want to force it to respond to a function because what's the point of that? But if you want it to respond in some syntax, then you don't want it to have any AI messages at all. You only want it to respond in that syntax. And so that's when you use that. And that's with the first use cases that we'll talk about, which are tagging and extraction. So amazing segue. So we'll import all the regular things. We'll now, so now we'll basically create a base model that describes how we want to tag the piece of text. So we'll say, hey, we want to get the sentiment and we want to get the language. You can see that we're using the description to encode a lot of information. So we're saying the sentiment of the text should be positive, negative, neutral. We're saying the language of the text should be in this ISO 639-1 code, which is basically the 2-letter code for the language. And so this gets back, like this is prompting. Like if we didn't put this, the language model, actually we can do that. We can remove this and see how the language model responds. But basically then we can see what the function looks like. We can create our model, create our tagging functions, create a prompt which has a super simple system message, and then we can bind it. So this is the main use case where we use this function call forcing thing. So here, like, it would be really silly to pass in two different functions, because we're going to force it to use tagging. So there's no point in that. But if we didn't pass in this, there is the possibility that it would not respond in that format. So we then create a chain, then we call it with this input. And so it responds with some nice tagging, arguments, sentiment positive, language English. And then if we do this again, this non mi piace questo cibo, I don't like this food, in Italian, so we can see that it does that, negative Italian. One of the things that you may notice, or something to notice here, is all of this, the only real piece of information is this bit right here. Because we know that this content is going to be null, because we're forcing it to call function. So we know that this is going to be null. We know that it's going to call a function. We know that the function it's called is going to be tagging. So the only thing that's really interesting is this bit here. And so we've added a output parser in LangChain that basically extracts only that. So we now can add this into the chain, again with this pipe syntax, and when we run it, we get back this dictionary. And so it basically just parses this out into this dictionary. Just for fun, let's maybe remove this and see what happens.
One question we have, when you call a function, does the AI message get generated first, and could it be used for chain of thought?
When you call a function, the AI message does get generated first, and it can be used for chain of thought. Yeah. Another thing that we can do for chain of thought. Okay, yes, that both of those things are correct. The one small issue there is that if you always want to respond, then you can't generate the content. So does that mean that you can't do chain of thought? Not really. So what we can actually do is we can add something like this here, and we can do something like think carefully about how to tag this text. And we run this now. We can see that the thought is positive sentiment towards LangChain. So it thinks a little bit. We can also do like think step by step. Expressing love for LangChain. Okay, so this is a relatively so thought, the user expresses a negative sentiment towards the food. Okay. So by putting additional parameters in here is one way that you can do chain of thought. Just for fun, let's comment out this description. And so now if we call the language model, we can see that it responds with positive and English. And so these are correct, right? But the whole point of tagging often is to get data in a specific format. And so while these are correct, these actually aren't in any particular format. And so actually, if we change temperature to that, positive English, I want to see if it responds in, okay, so we'll probably always respond in a row. This is okay, so here's a little bit different, right? So it responds with a lowercase Italian instead of a capital I. And so that's a minor, and here it responds with a capital I. So you can see that it's actually changing kind of like its response. And that defeats a little bit the purpose, because the purpose of tagging and extraction is to extract things in exactly the right format. So you need to be pretty descriptive about how you want things to be returned. Extraction is very similar, but we're now going to extract multiple pieces of information. So if you remember with tagging, we just defined this class. Now we're going to define a class, and we want to extract a list of this. So we're going to define a new class, which has this nested within. So this information class has people. People is a list of person. We really care about extracting a list of this. We can then do this. Same thing. We're going to force it to call information. So remember, we're giving information to it, not person. We can invoke it, and we get back some response. Again, well, if we do something like this, if we do something like this, we can see that we get back something that's string indices must be integers. Right, because I need to do the we can see that I get back the structured thing, but this also has a little bit of extraneous information. We know that we always want this people key, right? Like that's what we're extracting. We're only extracting one thing. So we have another kind of like function in LangChain, or an output parser in LangChain, that basically extracts JSON key output parser. It extracts the people key. So we run this, and now we just get back this list. So just some minor conveniences to make things fun to work with. We can see, oh, it actually does it well here. So we can see that sometimes it doesn't really know how to handle age. So here it guesses at her age to be 55. Here it puts -1. Here it doesn't include it at all. So one thing that we can do is we can put in the system message some more information about how it should handle this extraction case. And then when we run this, it should be better at oh, that's fun. So it looks like this didn't respond in JSON. So remember how I said that OpenAI functions doesn't always respond in JSON? Well, yeah, so it looks like there's some randomness here, because I'm assuming the model that we're using does not have temperature set to 0. Yeah, because we changed it to 0.9. And so there is something that is not JSON serializable here, which I think is going to be this tuple here. These tuples aren't a JSON thing. So some good live dealing with OpenAI functions not always returning JSON, and using Langsmith to see what's going on. And then I'm probably going to skip over this for the sake of time, but basically there's an example here of doing this for real for a larger body of text. So this is a more real world use case. We can load in a web page, and then basically we want to extract a bunch of all the papers that are mentioned in this article. It's a really long article, so we're gonna split it up with a text splitter. It's also a more complicated extraction thing, so we're gonna write a more complicated system template, and then we're gonna basically use the map part of LangChain expression language to execute on all these chunks in parallel. So I'm going to skip over this for the sake of time, but I would this is a pretty fun use case of doing like real world extraction over long documents, or over long documents that require you to split it up. So if that's interesting, I'd definitely check that out. Any questions about tagging or extraction?
I'm going to give you another layup because we're for the transition, but we had another question on the chain of thought, and could it be used for selection of which function to call? And I think we're going to get to that in the next section on tools routing.
Yes, exactly. Yes, it can be used for exactly that. So before getting into this, what are tools in LangChain and how do they relate to OpenAI functions? So OpenAI functions are just description of the thing to be called. There's nothing there that actually has the code to run that function itself. Tools basically combine that description. It's more general than the description, so you can use it for other things besides OpenAI functions, but it combines the description with the actual running of the tool itself, or with the actual execution of the function of the API of whatever itself. So it combines it into one object. And then that makes it easy to pass it around and call that object. We've added a nice little decorator. One thing that we've noticed is that we have a bunch of pre-built tools in LangChain, obviously, but for a lot of production use cases, most people are using their own tools, because a lot of like what makes agents powerful and interesting is hooking it up to your data, your application, and so we've added like this tool decorator, which makes it really easy to add on top of a function, and now it is a tool. So now it has a name, it has a description, got some args. All of these are automatically defined or automatically inferred by the tool decorator. We can also override some of the defaults. So if we want to provide more information about the inputs, for example, we want to add a description to one of the inputs, we can pass that in here. There's some other parameters as well. So this is just a really easy way to create this tool object. And with this tool object, we can still run it. So we can still invoke it, we can still call it. And so it combines kind of like, and we can also format it to OpenAI functions. So it combines kind of like the OpenAI functions description with the actual execution, all in one object. For here, we're going to define two real tools that we'll use. One uses OpenMedia to get the current temperature. You can see our name, description. We can get the OpenAI function description. We can call it. We can actually get the real current temperature for wherever this is. And then the other is Wikipedia. So we define a function. What it's basically doing under the hood is doing a search, getting the top 3 titles, getting the summaries of those pages, and then passing back one string with all 3 summaries. Get a name, description. We can run it. We get back for LangChain, doing the internet works. So we can see that LangChain is the first thing, but then the second one is sentence embedding, and then the third one is prompt engineering. Another thing that we can do is basically, so there's these things called OpenAPI specs, which are basically pretty standard ways of describing arbitrary APIs. And we can easily convert those into OpenAI functions. So this is a really, really powerful way to quickly onboard an arbitrary API that you might have inside your company or something like that. So what we can do is there's this fake OpenAPI spec here. And what we can do is we can load that, pass that to this function, and then we get back a description of all the endpoints that are in that. So we can see that there's 3. A list pets endpoints, create pets endpoints, and a show pet by ID. This is a fake. This is a pretty like fake canonical fake Swagger / OpenAPI spec. And it also comes back with callables. So if this OpenAPI spec was actually real, these would be functions corresponding to each of these different endpoints. So now, how do we use stuff like this? We can load a model, bind it with temperatures. Notice that we're not forcing it to use any particular function. We can then invoke it, and depending on the content, it chooses the right one to use. So list pets, show pet by ID. Gonna jump to an example where we use the real tools that we created. So the Wikipedia search and the get current temperature one. Oops. And then we can call it with some inputs, and we can get back the correct kind of like function calls. So get current temperature for the weather one, knows the longitude and latitude of San Francisco. What is LangChain? Searches Wikipedia for LangChain. We can use this model in a chain, so we can create a prompt with the system prompt. And so we can also do things like think step by step before selecting a tool, if at all. Okay, so it's not listening to its system prompt. So this is actually maybe a good. So why isn't it listening into its system prompt? Let's see if we can debug that. So one thing that we can do is we can open up Langsmith. We can see it here. We can then go into the playground. So let's see if we try it with GPT-4, will that fix it? Will it think step by step? It doesn't think step by step. So respond to the user with your logic, thinking step by step. And let's call it a function, because it might be. Okay, so there it goes. There it goes. So I actually wonder if it was. I wonder if it was just calling it a function instead of a tool. Or if my description actually. Okay, so my good description was the difference, not the function versus tool. But this shows a little bit how you can kind of like, and so here it's a little bit of a toy example because it's so it's just right here. But if you're using it as one part of an agent, which hopefully we'll get to soon, and there's some call, the third one down that goes wrong, debugging it with this playground is pretty nice. And then what we can do, and so then if we say in hi as well, it also just responds with content. So there's a few different modes that it can respond in, right? It can respond with content, or it can respond with a function call. And often downstreams, what we want to do is say, hey, if it responds with content, we want to return that to the user. If it responds with a function call, then we want to take that function. This is very similar to kind of like agents. So we have an OpenAI functions agent output parser, which basically parses this message into an agent finish or an agent action. And it's using the exact logic that I said before. So if there's something in content only, then it's agent finish. If there's anything in function call, then it goes into agent action. So we can see here we get agent action. We can see that there's a nice tool input. And the reason that this is the reason that it's useful to put this into this is this just makes it interoperable between other kind of like agent architectures as well. So we can use the same agent executor, which we'll get to later on, for OpenAI function calling, for just React function calling, things like that. So it puts it into this standard schema. We can then also call the function with the tool input, get back a response. And we see that if we call it with hi, we get back this agent finish. I'm going to skip this in the interest of time, but any questions before I go on to the agent stuff and wrap up there?
So would you recommend using an OpenAI functions agent in LangChain if you had kind of a complex workflow that you're not sure if it needs to call one tool or several tools and you can't predetermine what the routing or what the DAG might look like?
Yes. Yeah. I think the OpenAI function's probably the most reliable one at the moment, especially if you're using GPT-4. Cool. All right. So now putting this all together, this is all from the previous notebook. We're just defining tools. We're defining those tools. We're creating this chain with the output parser. Okay, great. So what we want to do now is we want to have some logic where if a tool is called, we want to call that tool, actually like invoke that function, and then we want to pass all of that back to the language model so it can kind of like continue and reason about the output of what to do. Note that this is for kind of like multi-turn conversational agents. You can also just use this to just do routing, but that's a little bit simpler. So basically what we're going to do is we're going to add this agent scratchpad. And so agent scratchpad is basically just a place to put this agent's work. And this agent's work specifically is like thinking about what function to call and then the result of calling that function. And we're going to have this be a messages placeholder because this is going to be a list of messages. And we can see what that list of messages looks like later on. So we're going to create this chain. It's now got this new prompt thing. So we now have to pass in this new list for agent scratchpad. We can get back, we see that we get this tool. We can call that tool with this input. We get back this observation. So now we've basically got this result, which is an agent action, and this observation, and we want to convert this to something that we can pass back in to the agent scratchpad. So we've got these two things. We want to put it into a format that the agent knows how to work with. That format's going to be a list of chat messages. It could be anything. Like you could put the agent scratchpad in like back here as like a string or something. But with since we're using OpenAI functions, it's a chat model. It uses chat messages. So we're basically going to convert the agent action and the observation into a list of messages, and we can do that with this format to OpenAI functions function. So we can call this on a list of tuples. So a list of the agent action and the observation. We get back this list of messages. Notice that it's using a function message. This is a new type of message that OpenAI introduced for function calling. And then we can invoke the chain again with the same input. And now we have this agent scratchpad, which is these things. And we can see that we get back an agent finish. Current temperature in San Francisco is this. We can put this all into a nice method that basically, when you pass in a user input, it creates an empty list of the intermediate steps, and then it basically just runs in a while loop until it finishes. We can also make a slight improvement on this. So if you notice, we're doing chain.invoke, and then we're so close to just passing in inputs directly, but we're actually doing this kind of like pre-processing step. And so what we can do is we can actually just put that pre-processing step as part of the chain. And then we can do a new thing, and now we're just calling the chain directly on these two things. This makes it very clean. Like this is just we're just working with the chain kind of like directly. You can see the logic that after we call the chain is if there's an agent finish, then we'll return with the result. Otherwise, we like look up the tool, call the tool, append it to intermediate results, go back to the beginning. And so now if we call it on what is the weather in SF, we can see that it responds. If we go into Langsmith to see what exactly is going on under the hood, we can see that there's a few new things that popped up. So these all popped up recently. And that's because it's making multiple calls, but they're not kind of like connected. And I'll show what it looks like when it's connected. But basically, this is the first time it's calling the agent. So it's getting back a function call. And then this is the last time it's calling the agent, and it gets back, get back a response. So the reason it's not connected is basically because this call, and then this call again are all kind of separate. One of the benefits of using the agent executor from LangChain is that it will lump those all together. It'll also do other things. So if there's a bad kind of like JSON decoding error, it's easy to handle that. If the tool errors, it kind of like accepts that. But at the end of the day, the main kind of like logic of the agent executor looks very similar to this. So if we run this now, it also has a nice verbose mode to easily print out things. And if we go back, we should see that we have an agent executor run. We look into it. We can see that we have first a call, then a tool call, and then another call. We expand everything. We can see exactly what's going on. We can jump to any point in time. We can now jump into the playground on this, and we can see what exactly is going into the language model. So this is the prompt that's been formatted. So there's the system message, a human thing. Then this is like what the AI called first, and then the function response gets back, and then the AI responds with this. And actually, fun fact, so this, if you notice, is really quite interesting. It does the right thing, but it says I couldn't find any specific information on LangChain. I think if you change it to that, it should work. Or at the very least, if you jump this up to 4, we can now see that I think, yeah. So this is often useful for debugging why agents aren't working.
And Harrison, we have a final question. Can you run tools in parallel so that way you can search the database and maybe search the web at the same time and get a response back?
Yeah, absolutely. So that's actually more part of the LangChain expression language thing. So in the LangChain expression language, and this is I'll maybe drop a link in here, but basically you can define a runnable parallel, which is basically just a dictionary. And then all of those elements in the dictionary run in parallel. So if you want to do kind of like two invocations to a tool or to a language model and then combine the results, you can just create a dictionary with two elements. Those will run in parallel, and then you can have another thing that pipes into later on, and that will combine those. And so we're gonna do a big push on LangChain expression language and add some good educational content there. But I just linked in the chat to something there.
Thanks for the questions. And if you have other ones, feel free to reach out at julie@langchain.dev. But thank you all for joining.
Thank you, guys.